A very good evening to all and welcome to my class. So today we are going to discuss paper. So I hope you all write your exam well and let's discuss some questions in which many students facing problems and by doing this question now, what is the main purpose behind this paper discussion, right? I already discussed with you many times the basic or the main purpose behind the discussion of paper is that you must know the concept, and by using this concept, if you know, if you're facing any difficulties in any question, then to don't just skip the question, right? Try to understand the concept behind this because maybe there will be a question in your coming examination related to this topic only, right? So it is very important to understand each and every concept in so detail. It nothing that you left one question or you can do one question or you can just skip the one question. That's no issue, but try to learn this as well. Okay, so I'm going to explain you or explain you the type of question in which you are facing some problems, right? So let's start with the today class and today's session with the paper discussion. Okay, so so the first question, and it is one of the very easy question, and we can say that, right? So this is very easy question, and what is the question asked, beta? In the following statement, which combination is true and false? And you have to identify the correct option, right? Out of these four options, which one is correct? So the first statement is ionic mobility is highest for iodide ion in water, right? As compared to other halide, right? So they are saying the the ionic mobility, right? So ionic mobility are much more. Ionic mobility is highest for iodine negative in water as compared to other halide, right? So and the next statement is what the next statement is, beta? Next statement is, yeah, next statement is that is IF5 is a square pyramidal and IF7 is a pentagonal pyramidal in shape. And the third is the reactivity order is like F2, Cl2, Br2, and I2. Is it true? That is iodine is more reactive than F2. Okay. And next move to the next statement, that is oxidizing power having order like this, right? So you have to identify which one is true, which one is false. And by knowing this, you can easily predict this. So the first one is that is the ionic mobility is highest for iodide negative in water as compared to the other halide. This is absolutely correct, right? So this is the absolutely correct statement. That is the ionic mobility is highest for iodide ion. So this statement is true, right? Okay. And the IF5 is a square pyramidal says this is also true. That is I whether it is a IF5 or we say BRF5, BRF5, right? IF5 or BRF5, both having a square pyramidal shape, and we know that IF7 is what is IF7, beta? IF7 having pentagonal pyramidal shape, right? So they having pentagonal pyramidal shape. So statement 2 is also correct, right? Statement 2 is also correct. It is absolutely correct. Okay. So next move to the third statement, beta, that is reactivity order. So this is not the correct reactivity order. Okay. So this is not the correct order because what we know now, the activity order of non-metal, that is if talking about the halogen family, then fluorine is much more reactive as compared to chlorine, bromine, and iodine. So this is absolutely false statement. Now on the same basis, if I'm talking about the oxidizing power, fluorine is the smallest and fluorine is the having highest oxidizing power as compared to the rest of the other element, that is chlorine, bromine, and iodine. So what is the correct option for this? What is the correct option, beta? What is the correct option for this? That is this one, right? That is D. That is T, T, and FF. That is first two statements are true and the last two statements are false, right? So I hope you understand the question well. Okay. Okay. Now, next move to the next question. That is what the question asks, beta. Which of the following is a pair of isoelectronic as well as isostructural species, right? So which of the following is a pair of isoelectronic as well as isostructural? So what do you mean by this term, beta? Isoelectronic and isostructural, right? So what do you mean by this term? Isoelectronics. Isoelectronics means having having same number of electron, right? Having same number of electrons, right? So having same number of electrons, right? So isoelectronics means having same number of electrons, and isostructural means having same hybridization, right? So if you found very interesting thing you observe here, that is if I'm talking about whether the number of electron or their hybridization, all the three species, that is whether option A, option B, or option C, all those having the same number of electron as the same, or we can say it have also having a same hybridization. So we can say that it is isostructure as well. So out of these three, let me discuss one, right? If I'm talking about CO2, right? So CO2 having how many number of electrons, beta? CO2. So we know that C having number of electron, beta, C. So C having number of electrons, that is 6, right? And O having 8 to the 16, that is 16. So 16 plus 6, 16 plus 6, how much? That is 16s are 20, 22, right? 22 electrons in CO2. I'm talking about oxygen, 8 to the 16 and 16 for 20, 22, right? Similar, if I'm talking about NO2, NO2. So number of electron in NO2, okay? Number of electron in NO2, right? So NO2, we know that N having number of electrons 7, O having 8, 8 to the 16. So 16 plus 7, beta. How much? 16 plus 7, that is 23. They having plus 1 charge now, just remove 1 electron. That it's also equal to be 22. So this is also 22, this is also 22. So both having same number of electron. On a similar way, and both having linear shape as well. We know that CO2 having linear shape, as well as NO2 also having the linear shape, right? So out of these three options, all A, B, and C both having the same number of electron as well as their isostructural nature. So the correct option for this question is D, right? So what is the correct option, beta? The correct option is D. Okay. I hope is it clear to you? Okay. ठीक है. So correct option is D. So इस तरीके से बेटा हम लोग इसको find out कर सकते हैं. I hope is it clear to everyone? No one having any doubt related to this question, beta? Okay. Right. Very good. Now move to the next question, right? That is question number 33. In question number 33, they are asking identify the statement which is not correct with respect to the surface phenomena. Right. So this question is basically from the surface chemistry, and they are asking ki out of this four statement, which statement is not correct with respect to the surface phenomena. Right. So now, if I'm saying if an adding electrolyte in emulsion, the conductivity increase, then it will be oil in water type repulsion, right? So if on adding electrolyte in an emulsion, the conductivity increase, then it will be oil in water type emulsion. The first point is this. Next is that is the Tyndall effect is observed when the refractive indices of dispersed phase and dispersed medium differ largely. And the third, that is the macromolecular collide are generally lyophobic in nature. They are generally lyophobic in nature. And the fourth one is that is the gases which can react with absorbent are generally chemiosol. So out of this, which of the following is not the correct statement? Yes, beta, absolutely. This is very simple to remember. That is macromolecule collide are generally lyophilic in nature, not lyophobic. So this is absolutely incorrect statement, right? So basically macromolecules like collide like starch, or we say galetline, they are lyophilic. Okay. Well, lyophilic means what? Water loving species, right? So they are basically water loving species, not water heating species. So this statement is absolutely correct for this question, right? Okay. Now move to the next question, and this is one of the good question, I guess. So what is the time required for the 99% completion of the first order reaction is nearly is equal to? So what is the time required, beta, for the 99% reaction? So we know that for the first order reaction, we know the formula for time, that is time is equal to nothing but 2.303 upon K, and this is log R naught by R. So this is the formula for finding the, we can say that it is an integrated rate equation for the first order, right? So now in this question, we have to calculate T99.9. So it comes out to be better 2.303 divided by K, and this is log R not always taken as 100. Okay, whenever the question is percentage type of question, then always take R naught assumes to be 100. Right now, out of 100, 99.9% reaction is completed already. So how many it left, beta? It is 0.1. Right, so 0.1. So here, what what T99 comes out to be, or we say what is K comes out to be here. K comes out to be 2.303 upon T99.9, and this is log, yeah, right, this is log, okay, and this is that is 10 raised to the power 3, right? This is 10 raised to the power 3. So this is K. Now we also know that for the first order, what is the half-life time? For the first order, half-life time is 0.693 upon K, right? So this is the first order reaction. This is the expression for the half-life time for the first order reaction, right? So T half is equal to 0.693 upon K. Okay, now just put the value of K here. So what you get, beta? If you put the value of K now, then you'll get 6.93. Just put the value of K here. So K, what is K, beta? 2.303. And this is log 10 raised to the power 3 divided by T99.9, right? I hope is it clear to everyone? Okay. Now this implies that 0.693 into T99.9 divided by 2.303, and this is what is 3 log, that is 3 and log 10 is equal to 1, so it will be 1. So on solving this now, we get what we get, beta, that is T99.9 is equal to 10 times of T half. So this is the correct expression for this question, right? So out of this fourth option, which one is correct, beta? That is option number B. So option B is absolutely correct for this answer, right? That is 10 times that the required for the 50% of the reaction. So B is the correct answer for this question, right? So I hope it is clear to everyone, and this is very good question. And really, this type of questions are generally asking in your examination. So please try to look at this question in a in a good way, and try to do question related to this topic, right? So if you do the 2 3 questions now, then you will definitely get to know that is what type of questions they are generally asked, and how to solve such type of question in a very less time. Okay, so just observe, there is they have a very short limited of time, so utilize your time. Okay, okay, now move to the next question, beta. That is question number 35. What is the question number 35 asks? What is the correct order of the bond angle, right? So the free radical of CS3 having bond angle is greater than free radical of CF3, that is CS3, carbon ion having greater than bond angle CS3. So we know that carbanion is lesser bond angle than the carbocation. So this is absolutely incorrect statement. If I'm talking about CH4 and CF4, then F is much more electronegatives than obvious CF4 having more as compared to CH4. Now similar on the basis of CH3 having more, not CH4. So what is the correct option, beta? That is the correct bond angle is like this. Okay, that is this one. Because in free radical of CF3, percentage of p character because of which bond angle decreases, right? So in CF3, due to the percentage of what? Due to the percentage of p character. In this, the percentage of p character due to the hybridization, with which bond angle decreases. If I'm talking about, we all know now, if I'm talking about sp3 having bond angle x1 degree, right? Similar, if I'm talking about sp2, they having bond angle of 120 degree. If I'm talking about sp, they having a bond angle of 180. So in this, the character of p is what? In this, the character of p is more. Oh, sorry, in this the character of P is equal, or we say is it equal to S. But in this the character of P is very less. In this the character of P is very less. So as the character of P is decreases, right? As the character of P is decreases. Okay, one thing must be clear here, beta. I'm repeat again because this can create a confusion for you. if I'm talking about, I'm right again here, sp3, sp2 and sp, right? So out of these three na, these having minimum p character, these having maximum p character. So this having maximum p character, right? And this having minimum p character. Out of these three, if I'm comparing, sp3 means as only 23%, and rest all are 66 and 70% are p only. So this having a maximum p character. So why the cs3 bond angle? Because there is a decrease in the percentage character of which bond angle decreases. So as the we know that as the percentage of p character also depends upon the bond angle being this, right? So this is the correct answer for this question, right? Now move to the next question, that is, in which of the following process haloform formation is favorable? So you have to identify the process in which the haloform formation is favorable, right? So let's see the solution for this question. Now, if I'm talking about the first one, that is acetone, and this is treated with Br2H plus, right? When the acetone is treated with Br2 in presence of H plus, then the formation of what takes place, beta? Let me write the solution. That is, whenever the CH3 is treated with, right, CH3COCH3, that is acetone, and it is treated with Br2 in acidic medium, right? Then the formation of, what, beta? Then the formation of, yeah, this one, this will takes place, that is CH3CO and CH3Br, right? So this reaction takes place. Now on the similar basis, if I'm talking B, so in B there is no reaction. Why there is no reaction, beta? Because in this you can observe that there is no alpha hydrogen at all, right? Now if I'm talking about the C, then HCBr3 is found along this. So which one is, in which of the following process haloform form is very much favorable? So this one, beta, because this is acetone, and we know that they will show which type of reaction, beta? That is Hofmann, that is sorry, not Hofmann, that is haloform reaction, like iodoform test, like that, right? Because aldehyde ketone undergo iodoform test, and those compound only go on iodoform test having such type of configuration, like CH3 CHOH, or we say CH3 COO. Such type of linkage only undergo iodoform type reaction, right? So option C is absolutely correct for this reaction, not option D, B, and A. Okay. So I hope is it clear to everyone, right? Now this question is very important, right? So you have to identify the product. Okay. So you have to identify the product formed in this question when the benzene is treated with this in presence of AlCl3 and H plus. So A form. Now when this A is treated with zinc amalgam and HCl. We know that this reagent we use in Clemson's reduction, right? Right? Okay. So when this is treated with Clemson's zinc, amalgam, and HCl, the compound B is formed. Now, when this B compound is treated with concentrated H2SO4, then this formation is takes place. You have to identify the structure of A and B. Okay. So you have to identify the structure of A and the structure of B. Okay. So these two are the desired equation, that is structure A and B, right? So you have to identify this A and B. So let's see what happened. In the first step, beta, when will it treat benzene with this, then the formation of, let me write here, right? Okay, I explain you by through this only. When the benzene is treated with this, then in the presence of AlCl3, then the formation of this will take place, right? And this is known as what? This is known as beta. This is a group, right? COOH group. This is group. This is alpha. This is beta, right? So this is a beta, okay. And when this treated with zinc, amalgam, and HCl, then the formation of this will take place. That is, here the one H is present. Yeah, this H. And when this treat with concentrated H2SO4, this H and H2O remove, and this will form, right? So elimination takes place in last step. So what is the A and B, beta? That is this one, right? So this is our desired product, that is A and B. So this A and B are formed in this reaction, right? Is it clear to everyone? Now, Now move to the next question, that is question number 38. In this question, what they ask beta, the number of geometrical isomer for the octahedral, that is CONH3 twice and Cl4 negative, a square planar. Let me write this as this one. This having whole having negative charge, right? So whole having negative charge and CON2 and 352. So you have to calculate the number of geometrical isomerism for the octahedral, a square planar, and this complexes. So we know that for the octahedral, right? For the octahedral, there are two type of geometrical isomerism. That is, this will show one cis and one trans, right? So one cis isomerism, one trans isomerism. So they having two. Now AOV3 has square planar and it's also so cis and trans. So it's also so cis and trans, right? And this having no isomerism, this will no show any isomerism, right? So they will no isomerism. So what is the correct option for this question, beta? That is 2, 2 and 0. So 2, 2 and no isomerism. That is 38 having B having correct option, right? So 2, 2 and no isomerism. So this is absolutely correct, right? Okay. Now move to the next question, that is question number 39. What question number 39 asks beta? Which of the following compound consists of PP linkage? Okay. So you have to identify, which of the following compound consists of a PP linkage. That is phosphorus linkage, right? Okay. So let's see the solution. If I'm talking about which of the following compound consists of PP linkage, first one is a hypophosphoric acid, next is a pyrophosphoric acid, next is a dipolyphosphoric acid, and the fourth one is a metaphosphoric acid. Okay, so you have to identify out of the following which of the following compound consists of a PP linkage, that is hypophosphoric acid, pyrophosphoric acid, metaphosphoric acid, and dipolyphosphoric acid, right? Okay. So let's see the structure of, let's see the structure of hypophosphoric acid, right? So let me write again. Yeah, let's see the structure of uh, hypophosphoric acid. So hypophosphoric acid having a structure like that, P double bond O. Always write the structure like this only. That is P. If having two P, then just write the structure like POPO. And this will having OH, OH, right? OH. Okay. And now there's a PP linkage, and this also form OH and OH. Except from these, no one having PP linkage, right? So which of the following compound consists of a PP linkage? That is hypophosphoric acid. Okay? Hypophosphoric acid. What is the formula for hypophosphoric acid, beta? That is H4P2O6. Right. So this is the formula of hypophosphoric acid, and this contain PP linkage, right? Phosphorus linkage. So I hope is it clear to everyone, right? Okay. Now the next question is which of the following element of lanthanide series have the highest tendency to show +2 oxidation state only, right? Only they want to show +2 oxidation state. So correct option is here, beta. That is EU. Why EU, beta? Because of the stability of the half-filled F subcell configuration. As soon as they show +2 oxidation state, they become 4F7. And we know that this half-filled are much more stable, right? This half-filled are much more stable configuration, right? That's why out of this four option, the question asks which of the following element of lanthanide series has the highest tendency to do +2. So the correct option is EU, because EU, as soon EU show +2 oxidation state, it become a half filled, and we already know that half filled and fully filled are much more stable as compared to any other state, right? So for this question, the correct option is A. I hope is it clear to everyone, right? This is the structure of this. They are isomerism and this one. That is because of the stability of the half-filled F subcell configuration, they are showing such kind of behavior. Now, next move to the question number 41, right? So what the question number 41 state beta? That is 1.0 molar with respect to each of the metal halide AX3, BX3, CX3 and DX2 is electrolyzed using a platinum electrode. For this platinum electrode, it is given electrode potential of reduction is this. For A3 to A, it is given as 1.5. Okay. So for A plus 3 to A, the value is given 1.50 volt. Similar for B plus 2 to B, the value is given like plus 0.34 volt. And for C plus 3 to C, reduction potential, their value is also given 7.4. And for D, that is plus 2 to D, that is minus 2.37 volt. Now, out of this four, now the correct sequence in which the various metal are deposited at cathode. So you have to find the various metal out of this ABCD, which will deposit it at the cathode first and which will deposit it at the last, right? So for doing such question, always remember that is reduction potential of water is what? That is reduction potential of water, right? That is reduction potential of water is, that is the reduction potential of water is minus 0.83 volt, right? So any metal or any having values greater than 0.82 must show the must show the deposition, or they are deposited at the electrode cathode, right? So they are deposited at the electrode, those having reduction potential values greater than 0.8, what, 0.83 beta, right? This is 0.83. So out of this four, how many of are deposited beta? That is A, B, and C. Both three are these three are deposited, right? And out of these three, which having maximum electrode potential value, beta, that is A. So the correct order for this question is, yes, beta. What is the correct option? That is first of all A, then B, then C. D will show no, because D having value greater than the reduction potential of water, that is 0.83 minus, right? So the correct answer for this question is C, that is ABC. Now, move to the next question. That is, in this question, they are asking what happened when this is treated with alcoholic KOH. E2 reaction takes place, that is elimination reaction. You have to identify the A. So the correct answer for this question is this. That's how can this will be performed beta? Let's see the solution for this, right? But the correct answer is B. So let's see the solution. We know that this will, whenever this is treated with the, right, whenever this is treated with the alcoholic KOH, elimination takes place, and we know that this form is less stable, so the formation is like that takes place, that is CCS3, C6H5, CH3 and HBr, right? So this is the final product for this reaction, that is 42. Now in this question number 43, what the question asks beta? In this, when the OCS3, that is, it is also known as, yeah, it is also known as anisole group, right? So whenever the anisole, this is dianisole, because both para position, they are opposite to each other, OCH3 group. When this is treated with concentrated HI excess, okay, when we take HI in excess, so when this is treated with the concentrated HI excess, then products of reactions are. So what are the product form for this reaction beta? So we know that for this now, OH group of phenol cannot be replaced. Okay, OH group of phenol, right? So for question this, OH group of phenol cannot be replaced by iodide ion. It does not undergo nucleophilic substitution reaction under the normal condition. So it will not go nucleophilic substitution reaction. So products and products of the reactions are, that is C. Why beta? Why C? Because OH group of phenol cannot be replaced by the iodine, as it, yes, as it was not undergo nucleophilic substitution reaction under the normal condition. So that's why the correct option for this question is 6. Now, in this question, in which the following CO bond length is longest, always remember the complex having negative charge. The complex having negative charge is always having longest CO bond length, right? The complex having the negative charge always having the longest CO bond length. So out of this four option, only option D having negative charge on its complex. That's why they are longest. Their CO bond length is longest there, right? So now move to the next question. That is question number 45. Which of the following is a chiral analgesic? So you have to identify the chiral analgesic. Out of these, now which one is a chiral analgesic? So we know that ranitidine is an antacid, right? Ranitidine is an antacid and dichloromethane and aspirin are a chiral, right? So what is the correct answer for this question is beta? Ranitidine is what? Ranitidine. That is ranitidine is antacid. Okay, so ranitidine to antacid ho gaya. Ranitidine is antacid. Whereas the dichloromethane and aspirin, they both are beta a chiral. So which of the following is a chiral analgesic beta? That is ibuprofen, right? That is ibuprofen. Ibuprofen is a chiral analgesic here. What is analgesic beta? Analgesic matlab which reduce, they are like a painkillers, okay, which is used to reduce the pain when we feel basically there is a two type of drug for analgesic category, narcotics and non-narcotics. So non-narcotic drugs are those which are not advised to use these type of drugs, and the one is which produce, induce some sleep as well, where the narcotic and non-narcotic means which just used to reduce the pain, right? And there is no side effect of this. So which of the following is a chiral analgesic? This is ibuprofen. So this question is coming from the chemistry in everyday life, that is drugs department. Okay, now question number 46. So according to question number 46, which of the following monomers has the greatest ability to undergo cationic polymerization, right? So which of the following monomer has a greater ability to undergo cationic polymerization? And for this, the correct option is like this. Okay. So you have to identify out of this which one having greater cationic polymerization. Okay. So just observe it carefully. That is, methoxy group stabilize the cationic intermediate by plus M effect, right? By plus M effect. So which one is the correct one? That is this one, right? That is 46 having correct option. C is N is 2 and C is double bond CH. Now, in question number 47, what they ask, beta, what the question number 47 demands from you? That is the tooth system, that is PCl5 decompose into PCl3 plus Cl2 and CoCl2 and CO plus Cl2 are simultaneously, right? They are in equilibrium in the vessel at a constant volume. If some CO is introduced in the vessel, then at the new equilibrium, the moles of, this is not the moles, this is the moles of, right? This is correct is moles. Moles of, right? So two system and these are in the thermal equilibrium, right? So sorry, two system PCl5, they are in a chemical equilibrium, and CoCl2 are simultaneously equilibrium in the vessel at a constant volume. Volume is also constant. Now, if some CO is introduced in the vessel, so if you introduce some CO in the vessel, then at the new equilibrium, the moles of, so PCl moles increase, PCl moles decrease, and the PCl remains unchanged and Cl2 increase. Okay, so we know that, right? When we know that whenever the according to the Le-Chatelier principle, whenever the reactant is added, equilibrium shift in a such direction, they want to decrease the reactant. That is in forward direction, right? So if I'm talking about this now, Cl2 is present in simultaneously in two equilibrium. Both Cl2 is present in the COCl as well as PCl2, right? So decrease in its concentration shift both equilibrium forward, because we know that according to the Le-Chatelier principle, what we know? According to Le-Chatelier principle, we know that very well. That is, suppose this is reactant and this is product, right? So whenever the concentration of reactant decrease, whenever the concentration of A or we say B decrease. So whenever the concentration of A or B decrease, right? So whenever the concentration of A and B decrease, the equilibrium shift in a direction where they want to increase the concentration of A and B. Okay, so just try to think in a opposite way. When the concentration of A increase, or we say when the concentration of reactant increase, the equilibrium shift in a direction where they want to decrease the concentration of the reactant. That means they carry the reaction in the forward direction. On the similar basis here also, at the if some CO is introduced, so CO is introduced. CO is which is product side. When the some CO is introduced, the equilibrium shift in such a direction, then they want to decrease this CO, and this will happen only when the reaction become what, forward or backward? Yes. So the correct option for this question is that is the PCl5 is decreases, right? That is the PCl5. The concentration of the PCl5 will start decreasing. Okay, because Cl2 is having both in having both the system, and that is in a first statement as well as the second statement. So if some CO is introduced, then equilibrium shift in the backward direction. So backward direction means what? There is a decrease in the PCl5, right? So PCl5 is decreases. I hope is it clear to everyone? It is totally based upon the Le-Chatelier principle, that is chemical equilibrium beta. Now, next move to the next question, that is question number 48. The curve in the figure show that the variation of pH during the course of titration of weak acid with a strong base, at which point in the titration curve the concentration of acid equal to that of its conjugate base, at which point beta. So this is a graph between pH. This is a graph between pH and mole ml of NaOH used. So this is point number A, in which mole mole of NaOH used is 0 at B, C, D. Suddenly from B to CDE, there is a suddenly increase in the curve we observe, right? So the question asks, at which point in the titration curve is the concentration of acid equal to that of a conjugate base, right? So the correct option is that is D, that is point number B. Why beta? Point B represents exactly the half neutralization, right? Point B represents exactly the half neutralization of acid. At this point, the concentration of acid left and its conjugate base are equal. So this point beta. So this point represents the, yeah. So this one is our required answer for this question. So I hope it is clear to everyone, right? At which point the question asked, at which point in the titration curve the curve is concentrated of the acid equal to that of its conjugate base. So this is the correct one, that is point B. Because here in point B now, the point B represent exactly half neutralization of acid, right? Exactly half neutralization of acid. At this point, the acid left and its conjugate base are equal. So this is the correct one. That is option number D. Okay. So option D is absolutely correct. Now, move to the next question. That is the minimum mass of NaBr which should be added in 200 ml of 0.00004 molar AgNO3 solution to start precipitation of AgBr, for which Ksb value is already given 4 into 10 to the power minus 13. Right. You have to calculate the minimum mass of NaBr, which should be added in 200 ml. So we know that for this, we know that that is the concentration, right? So this is the concentration of Br negative. If you want to calculate this now, then it will comes out to be 4 into 10 ki power minus 13. Okay, 4 into 10 ki power minus 30 upon 4 into 10 ki power minus 4. Right? How that comes out to be better? कैसे आया ये बताओ तुमने? Yeah, that comes out to be 10 raised to the power minus 9 meter. Okay, so we know, because now we know that na KSP of AgBr and Br is given. So by using this, we can calculate. So this comes out to be, concentration of this comes out to be 10 ki power 9, right? 10 ki power minus 9. Now, what is the mass of NaBr? So mass of NaBr used 200 ml, right? So mass of the NaBr used in 200 is equal to what beta? That is 103 10 की power minus 9. Okay, so that is 103 into 10 raised to the power minus 9 divided by 1000. Let me write, right? Into 200. So what is the correct answer for this question, beta? 2.06, 10 ki power minus 8 gram. Right? So this is the mass required. So this question is totally based upon KSB and the normal calculation, right? So I hope this is clear to everyone. No one having any kind of doubt in this question. Shall we proceed to the next question, beta? Okay. So let me tell this. Let me first of you. Let me tell the answer for this question. That is, in which of the following cases is the value of x maximum? Okay. So you have to calculate for which of the following the value of x is maximum. Right? Just calculate this, beta. Just calculate this, beta. Just take water, some water. Till you try to just find it out. Right? Okay, beta. So in which of the following cases is the value of x is maximum? So you have to identify the maximum value. That is, we know that for C, that is this one for MgSO4, right? MgSO4.x is 2. We know that greater the charge density, greater is the hydration. So greater the charge density, if I'm talking about, beta, mange, car, scooter, bap, raji. This is for second group, right? So we know that magnesium having more charge density as compared to calcium and barium, right? So out of these three, which one having maximum value of x, beta? Which one having maximum value of x? Yeah, that is MgSO4. So MgSO4 having maximum value of x, right? I hope is it clear to everyone? Okay. Now, the one is very, very important question, that is the number of incorrect statement of the following statement is. You have to identify which statement is correct, right? Sorry, which statement is incorrect. The first one is H plus is the smallest size of cation in the periodic table. So it states that H plus is the smallest size of cation in the periodic table. Next, van der Waals radius of chlorine is much more than the covalent radius. Ionic mobility of lithium ion is greater than that of hydrated sodium. This is correct. He atom has the highest ionization enthalpy in the periodic table. This is also correct. Yeah. So which of the following is incorrect, beta? That is first. Okay. So there is only one incorrect statement. That's the first one. That is H plus is the smallest size cation in the periodic table. Now move to the next question, and this one is going to be very, very important. That is, how many dichloride cyclopentanes, including stereomer, are obtained when cyclobutane react with the excess of chlorine at the high temperature, right? So this question states that how many dichloride cyclopentanes, okay, how many dichloride cyclopentanes, including stereoisomer, are obtained when cyclopentane react with excess chlorine at high temperature. Okay, so you have to calculate this value. So let's see the solution for this question, right? So this one is our no the question is given, and this become cis and transform, and these two pair are known as an enantiomers pair, right? And these two are the optically active. The total they having 7 types. That is one structure, 2, 3, 4, 5, 6, and 7. The total they showing 7 type of, right? So what the question asks, beta? How many dichlorocyclopentane, including stereomerism, are obtained? So the correct answer is 7, right? The total isomer is 7. Now, next move to the question number 53. Okay. So what the question number 53 state, beta? 53 state that the number of alpha hydrogen present in a major product obtained when the following substrate is substituted to E2 reaction, right? So the correct option is 10. So it's a very simple one. Just try to learn. I hope it is clear to everyone. Okay. Now let's move to the question number 54. The number of paramagnetic complexes from the given compound. So you have to identify the number of paramagnetic complexes, whether it is NiCN4, NiCl4, COCl6, COF6. So you have to identify this. So we know that COCl4 twice negative. So COCl4 twice negative, Cl is a weak ligand. So for weak ligand, right? For the weak ligand, and CO is an oxidation state of what beta? -4, -2, -6. That is X minus 4 is equal to minus T. The X is equal to -2 plus 4, 4. The X is equal to plus 2, right? X is equal to plus 2. The X comes out to be plus 2 here. Plus 2 means what? That is cobalt. So cobalt plus 2 having electronic configuration. Science teacher very cruel mange fair copy. That is CD7. So this will having hmm, right? 3D7, right? 3D7. So with the number of paramagnetic complexes, you have to identify. So whenever the weak ligand are present, now, so why can't this? Because in this, the oxidation state is 2, like cobalt having +4 oxidation state. So as the oxidation number increase also, then this is also not possibility of getting this value, right? So the number of paramagnetic complexes for the given compound is how many beta? NiCN4 is a DsP2 hybridized and it is a diamagnetic because strong ligand. Whenever the strong ligand is present, they are always diamagnetic in nature, right? On the similar basis, the number of which of the following other elements are better? NiCl4, the weak ligand, right? So the correct answer for this question is 3. That is this one, NiCl4 because weak ligand are there, COCl4 weak ligand are there, COF6 weak ligand are there. So total number of possibilities is 3. So the number of paramagnetic complexes from the given compound is 3. Is it clear to everyone? Just remember this simple trick. As the ligand is weak, number of unpaired electrons is more. So this will show more paramagnetic behavior. Right? Okay. Now let's move to the next question. That is number of electron having Ml0 for the sodium atom. So for sodium atom, we know that sodium atom, this is 1s2, 2s2, 2p6, and 3s1. Right? So number of electron having Ml0. So this having Ml value 0, 0, 0. So 1, 2, and 3. So, okay. So how many beta? That is how many of having Ml is equal to 0? Tell me fast. Yeah, that is 7. How can you say that 7 beta? This having Ml 1s2. So they having 2, 1s2, 2s2, 4, and this is 3s1, right? So this having values. How we can write now? 1s2, 1s2 like 1s2 means what? They having 2 structure. So they having Ml value 0. Okay. Now 2s2 also having 2 electrons only. They are also having 0. Now if I'm talking about 2p, 1, 2, 3, 4, 5, and 6. So they having like value like -1, 0, and 1. Again 3s2, they also having a value like 0. So how many 0? 1, 2, 3, and 4. So total number is how many beta? The total number is 4, right? So the total number is 0, 1, 2, 3, 4. The total number is 4. The number of electrons having Ml is equal to 0. 4 means what beta? 4 means this is 4 orbitals, right? 4 orbitals. And we know that in every orbital there are 2 electrons. So 4 orbital means 8 electrons. So this is correct क्या? क्या ये सही है? 8 electrons? No beta, because here only 1 electrons are there in 3s1. So only 1 electrons are there. So how many electron beta is having orbital? 1 orbital and 2 orbital, right? 2 orbital and this 3 orbital. 3 to the 6 plus 1, that is 7. So not 8, the correct answer is 7 electrons. So this is very important question, and many problem facing the problem in such type of question. Even though the question is not too hard, or we can say that yeah, it is difficult to attempt, but it consists of some small step. If the concept of the students are not get clear now, then they are not able to solve this question. right? So the number of electron having Ml is 0 is equal for the sodium atom is equal to, similar for magnesium atom beta, you have to calculate, right? You all have to calculate for the magnesium atom. So just calculate number of electrons having Ml is equal to 0 for magnesium atom. Then you got to know that is it comes out to be 8. How come beta? How will come out to be 1 8? Because 2s, 2s, 1s, 2s, and 3s. So they having a 3 orbital of s and 1 p orbital. So 4 and each having two electrons. So 4 to the 8. So 8 is the correct answer, right? Now, the next question is, that is question number 57. The number of non-polar molecule from the given molecule. You have to identify the number of non-polar molecule. So we know that in a PCl2F3 net dipole moment does not cancel out. Okay, so in this only the dipole moment is not cancel out. Rest all are showing. Rest all are dipole. So the number of non-polar molecules. So non-polar molecule is what? That is PCl2 and F2, right? So PCl2, F2. Okay, so this one. So out of these three, okay, so these three are the following. Okay. Next, move to the question number 58. What the question number 58 suggests, beta? In NaCl, lattice Cl constitutes CCP lattice and Na occupy all the octahedral voids. What is the total number of third nearest neighbor to the Cl atom? Right? So it consists of corner Cl ion on the third nearest neighbor and the body center Na plus ion. So the correct answer for this question is that is 8. Right? So the 8 is the correct answer. Now, what happened? Yeah, how we can say that how many molecule of RMGX has consumed in the below reaction? So the reaction is given below. So you have to identify how many molecules of RMGX are consumed in the below reaction. So let me write the reaction first, right? So if you write the reaction, then you just need that is the 2 mole of RMGX, okay, are consumed by the acid chloride group and undergo addition elimination first and then addition. The other aldehyde and ketonic group consume or RMGX mode each is 4. So how many moles of RMGX beta? 4 moles. Right. So this is the 4 moles of this are required. Now, structure containing, you have to identify among the following total number of aromatic compounds. So total number of aromatic compound, it must be planar. It must be sp2. Okay, and one the important thing is it must be follow Huckel's rule. That is 4n plus 2 pi electrons. Okay. So any compound, any element which show these type of structure with having planar or sp2 hybridization, 4n plus 2 pyrrole, they follow, then they're supposed to be aromatic in nature. So out of these now, how many of you actually see that they've showing this effect, showing this planar shape plus 4n plus 2 pyrrole type of this? Out of this, which of the following beta? Yes, tell me fast. Okay. Whether the first one, it will show or not beta? It having this type of configuration 4n plus 2 or every having sp2. Yeah, this one having sp2, 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 sp2. Right. And they having planar in nature, right? So they will follow 4n plus 2 pi rule. They will follow or not. For example, 4n plus 2 pi rule, right, is equal to how many? That is, it is equal to only 2. That is 2. So 4n is equal to 2 minus 2, that is 0. So n is equal to 0. This will not follow, right? And comes out to be 1, 2, 3 on. So out of these three, two, right? Out of these three, two, you have to identify which one is the absolutely correct for this. So the correct answer for this question is, what is the correct answer, beta? That is C, right? So you have to identify for this the total number of product is possible. So total number of aromatic compound possible for this compound is beta. Yes, tell me fast. Total number. How many of total number of following beta? Yeah. Yes, that is 4. So this one is absolutely correct. So that is 4 is the total number of aromatic compound for this reaction. Yeah, let's see that solution as well. That is 4. Structure of containing a ring of 4n plus 2 pi electron is aromatic. So those having containing this type of ring are aromatic in nature. So I hope is it clear to everyone, Hannah? हम लोगों ने क्वेश्चन सॉल्व किए and and we just look at the question which you facing students facing some problem and try to understand the concept behind this question as well. So just focus on this and try to do much more question as you can, and let's summarize this class here. Okay, so in this we are discussing about the MCQ PYQ questions and the basically the question that you are facing problem in your today exam. Okay, so this is basically the paper discussion today. So in next class, we are going to start our new chapter like, biomolecules and this one. So they are also very good scoring chapters. So just be with me, and in next class, we are going to start this chapter. Till take care and study well and prepare for your exam. We'll meet you again. Till take care. Bye-bye.